Hello and welcome. Are you somebody looking to achieve one of the very highest grades possible in GCSE Mathematics? Well, if you are, please continue to watch this video that addresses the topic of Surds beyond the basics. More specifically, we're going to be looking at the addition, the subtraction, the multiplication and division of Surds. And you can see there that we have a challenge today of being able to rationalise Surds. Now, as I've said before, when we look at these higher topics, most often we will need to call upon knowledge from our previous learning. And this particular session is going to require your knowledge of factors, obviously square numbers, that of expanding brackets, and also that of dividing or cancelling out when you have an algebraic expression. But please, if you're looking to achieve one of the highest grades possible in GCSE Maths, then please continue watching. If we take this first question, we're being asked to simplify the square root of 45. Now, before I look at that question, I'm just going to move over to the right-hand side here. Nothing to do with this question per se, but let's just say I'd asked you the very easy question of simplifying, I don't know, I'll make a fraction up, 20 24ths. You might say 10 12ths. Well, that's simpler, but it's not simplest. Actually, it simplifies fully to 5/6. Now, those fractions, they don't actually change in size. They're all the same value. It's just we've rewritten 20 over 24, 20 24ths, using smaller, more manageable digits with 5/6. But we haven't changed the size. Now, we must adopt exactly the same approach when simplifying surds. We can't change the value. Now, how we do this is we take the highest square factor. Notice I didn't say the highest factor, it has to be the highest square factor. The highest square number that is a factor of 45 is 9. However, we've got to keep our initial value. So what do we times 9 by to get 45? Very straightforward, I hope you think. And that's 5. 9 times 5 gives us 45. We can then write our final answer as 3 root 5. As always, we're going to build up the level of difficulty gradually as we go through. So let's look at question 2. And question 2, I can see straight away we're calling upon our prior knowledge of expanding double brackets. So I'm just going to set things up. Root 5 plus 2 in our first bracket. And in our second bracket, we have root 5 minus 2. Now, you might use the FOIL method, you might use the grid method. I'm just going to try and talk you through each step in how I'm expanding this double bracket. Root 5 times root 5 will give me root 25. Root 5 times negative 2 minus 2 root 5. 2 times root 5 plus 2 root 5. And then 2 times negative 2 is minus 4. I can start to tidy things up a bit. The square root of 25 is 5. Minus 2 root 5 plus 2 root 5 minus 4. If I take a different coloured pen, we can start to cancel out, because minus 2 root 5 add 2 root 5 would give us 0. So what are we actually left with? 5 subtract 4, and that equals 1. We've expanded and then simplified our initial expression. So moving on to question 3, we're starting to now introduce this word rationalise. Well, what rationalise means is, if there is a denominator to our expression, we're not allowed a surd, a square root, in that denominator. But all the time remembering, we're not allowed to change the value of our starting expression. So if I just write that out, 4 over 2 plus root 3. And I'm just going to set something up here. You'll notice I've left a gap. I'll try my best to explain why. Now, I've already said it a few times, we can't change the value of our starting expression. In my opinion, there is only one number we can multiply by that does exactly that, and that's 1. So whatever is in the numerator here has to be in the denominator. But we've got to eliminate this positive root 3. So we've got to introduce the inverse of that, which is negative. But if it's in the numerator, it has to be in the denominator. What I actually say to myself is we multiply the denominator over itself, but with the inverse symbol. I can now start to work that out. 4 times 2 is 8, minus 4 lots of root 3, over 2 times 2 is 4. 2 times negative root 3 is minus 2 root 3. Root 3 times 2 will give us plus 2 root 3. Root 3 times negative root 3 minus root 9. Now let's start to tidy things up. Well, we can't do a lot with our numerator for now. 8 minus 4 root 3. However, let's look at this denominator. Well, I'll take my different coloured pen again, just for consistency and clarity. Minus 2 root 3, add 2 root 3 will cancel out. And that will leave us with 4 subtract the square root of 9. The square root of 9 is 3. So that will leave us with 8 minus 4 root 3. Not only have we eliminated our denominator, the surd in our denominator, we've rationalised, we've actually eliminated our denominator altogether. The reason being 4 subtract 3 is 1, and anything divided by 1 is itself. Now let's just read the question. Give your answer in the form A plus B root 3. Well, we've done that. But remember those initial videos, mathematical reasoning, mathematical justification, have you shown all of your working out and your understanding? Let's be absolutely clear, we know what we are on about. So in this case, A equals 8 and B equals negative 4. So now let's move on to question 4. And in question 4, we're really starting to approach and attack a grade 9 level question. X equals root 5 plus root 2 and y equals root 5 minus root 2. Of course, without using a calculator, find the exact value of x squared plus y squared. Well, let's just write out our initial expression for x, root 5 or plus root 2. Therefore, x squared will equal root 5 plus root 2, and I'll put that in brackets for clarity, multiplied by root 5 plus root 2. And once again, I'm putting that in brackets. So let's expand those brackets. We will get root 25 plus root 10 plus another root 10 plus root 4. What does that give us? 5 plus, well, we've got 2 root 10s, add 2. The final stage in our simplification, 7 plus 2 root 10. I've now got to do exactly the same thing for our y value. That's root 5 minus root 2. Therefore, y squared equals root 5 minus root 2 multiplied by root 5 minus root 2. I'm putting both parts in brackets for clarity. What will that give us? Root 25 minus root 10 minus another root 10 plus root 4. Let's start tidying things up. Root 25 is 5. I've got minus 2 root 10s, and the square root of 4 is 2. So that will give me 7 minus 2 root 10. So I've worked out x squared, I've worked out y squared, but read the question. It's saying what is x squared, so 7 plus 2 root 10, add y squared, so plus 7 minus 2 root 10. For consistency, I use my different coloured pen. Plus 2 root 10 minus 2 root 10 will cancel out. So I'm left with 7 add 7, which is 14. And there we have it, an introductory lesson to Surds beyond the basics. If you want further practice, please check our resources, with which of course there's always an accompanying video that goes through the solutions. But for now, good luck in your quest for achieving one of the highest grades possible in GCSE Maths. Thank you for watching.